skipped a few things there. All right. So back on this, what we're doing is we're trying to write or test our software in the way the user uses it. And all that means is let's select an element in the DOM in a way that the user would be able to with their eyes. So something like by the text that's displayed, by the value that's in an input. There's a few other things we can use as well. Placeholder text, label text, those types of things are things the user sees on the screen. So those are things we'll use to select our elements in the DOM when we want to click a button, for example. That's the difference would be other than that, you could, with jQuery, for example, select an element by a class name, but the user doesn't know anything about class names. So the user isn't clicking a button based on its class name. They're clicking it based on the text that they see on it. So that's why we're going to stay away from finding elements based on class names, because even if the class name changes, and we're talking about CSS classes here, we select elements by CSS class. If that changes, then we need to update our test. But potentially the user didn't really see a change. Maybe they saw a different background or something like that. That's not really how the user interacts with the software. So here's the principle we're going to follow, and you'll see this roll out. And you've already seen it in the tests that you've been exposed to so far. They follow this principle as well because they use this tool. And that brings me to this topic here, which is tools versus testing. I'm going to teach you specific tools, including Jest and React testing library, and I'm going to teach you general testing process. And those are two very different things because the tools change depending on what tech stack we're using or even what year we're in potentially. I would say right now we're in generation 2 of JavaScript testing. And previously, generation 1 would be using tools like Mocha and Chai or Enzyme for React testing. Those are older tools. And the next generation of things like Jest and Cypress, which you'll use tomorrow, and the React testing library and the DOM testing library, those are more like generation 2 of testing, learning from the previous generation and trying to improve things. This principle seems to come out from that transition from generation 1 to generation 2. They learned a lot, people learned a lot, we learned a lot about testing in generation 1, and now we're applying it to the new tools. So tools change, it just happens. Maybe there'll be a generation 3 and you'll have to learn those tools as well. But what we talk about when it comes to testing today, that's going to be generally applicable to any project using any technical stack. Okay? And when I say testing, I mean really building up a test strategy for your project. This is something that doesn't necessarily come natural. Maybe it's not even clear what this could mean, but it's really about how do I balance out the testing so that with my budget, my testing budget. I have a budget for the amount of. Do people use Mocha in industry still? Yes. So I would say in the industry, Mocha and Chai still in use. If you were to look at the internals of Cypress, again, which we're going to use tomorrow, they use Mocha and Chai internally in Cypress. So I guess technically we will use Mocha and Chai tomorrow, but just through the Cypress tool instead. Make sense? I think, yeah. So still in use, still popular. And also as a note for tomorrow, when you're using Cypress, you can use the jQuery selectors that you're used to because Cypress also has jQuery built into it for selecting elements in the DOM. There's a lot we can do. Cypress can do unit testing and integration testing and end-to-end testing. But I like to use it really just for end-to-end testing. I like to use Jest for unit and integration testing. And that's kind of how it's rolled out for me. So I think you'll get a little bit of exposure tomorrow to end-to-end testing with Cypress. And that'll end up using, I think, some selectors that you're used to. Okay, so back to this. We've got strategic testing, which is really about more process than anything. Let's see. Okay. So on the weekend, there were videos from people about creating test strategies or about how to test. And they would liken their test strategies to different shapes. So I know we saw a pyramid, right? The testing pyramid. anyone want to talk about the testing pyramid, what they thought? You don't have to label the layers or anything like that. But what is the purpose of trying to describe a test strategy that has layers like that using a pyramid shape? What does that signify?
It seems like you're kind of starting at the small individual parts, and then you're working your way up to components, and then modules, and then I guess like maybe your whole application as a whole.
Okay, cool. Yeah, exactly. And so there's an idea of kind of scope in this, right? In the sense that starting down here, you might start with small tests, and then as you go up, bigger and bigger tests that take more time to maintain and cost more to maintain, so you do fewer of them. So with the pyramid, they're saying, I think at the bottom you might have static testing, so lint and or TypeScript or something like that, and that's going to provide essentially some level of testing to every code file in your project. So the scope is quite large, and then you go up another layer, and here you might do some unit testing, and that's going to be specifically maybe some functions or specific components. Then you go another layer, and that's integration testing, and you do fewer integration tests potentially than unit tests. That's why we're going up the pyramid, and at the top might be end-to-end tests, which we only do a few of, and maybe just for the happy cases. So when I think of end-to-end tests, I think of the tests that you run before you commit your code right now manually. Those are the types of tests that I would think of. I go through the app and I check that a few things work generally. Whereas unit testing, kind of down here, is more about let me find a specific part of the app and test it quite thoroughly. Now, Kent came out and said he wanted to instead do a testing pyramid, and he quoted Guillermo Roche on Twitter, I think, saying, uh, write tests, not too many, mostly integration. So that's different than what the pyramid scheme, I guess, for lack of a better word, is trying to get us to do. In this case, they're saying write more integration tests than any other kind of test, because when it comes to testing potentially user interfaces, which I think is what Guillermo was talking about, and Kent is definitely talking about user interfaces, that integration tests are probably going to provide more value for you. So we will write tests that also test multiple components together at the same time, and that would be an integration test. I don't know if there's a teapot strategy. I just put that on there because it's another shape, but maybe there is. What is this spout all about? What's this handle? How does that play into it? Who knows? Maybe someone will come up with it, and if you do, let me know. The shapes don't matter. Your strategy might be different. You might choose a different approach for every project that you work on. That's kind of what I want to get through today. So in the notes I've put a couple of different. Here, actually, I'll bring those up. I think I can do it here. And I'll just highlight these. So when we're talking about, make it bigger even. When we're talking about building up a strategy, ask yourself these questions. So what are the most important mission critical parts of our application? We should focus our testing there first. That's the important thing. And if it breaks, it could cost us a lot of customers. That would be things like sign-in flows, ordering and checkout on an e-commerce website. Those are mission critical. Those sites might as well not be there if those features don't work. Whereas maybe something minor, something on a profile page, something people don't see very often, maybe you don't test that right away. If there's a bug in it, maybe you come back and test it later. But we still have to choose. So we'll start with the most important mission critical parts of our application. What is the process we follow when we find a new bug with manual testing? And that could be answered a few different ways. I think right now what happens is people fix it. That's great. We should do that. But there's something we should do afterwards as well. And that's going to allow us to ensure that bug does not come back in the future of this project. We'll talk about that type of testing in a little bit here, but super important that every bug we find through manual testing is recorded so that we know if it ever comes back or not. What is the starting balance of our different categories of tests? So we've got this idea here that there's these layers of testing, and based on the shape we choose, we might do more or less. But what is that starting balance? So that's kind of like, which shape should we choose? at the very beginning, because we can't choose what the end shape will look like. It's very possible our tests will change based on the features we write. As I write a new feature, I might think, oh, I should write a whole bunch of unit tests for that, and then blow my entire unit testing budget out, make it super fat, and everything else looks like it's a lot smaller. Well, that's no problem as long as I have confidence. That's all I'm looking for is confidence. So I want to choose the right type of test for the feature I'm testing, and I'm not going to follow that shape rule if it doesn't actually fit with what I need to do now. Does that make sense? I'm kind of trying to sort of explain. Don't just get fixated on the shape and say no. I've written too many unit tests. I got to stop now. If that's the best type of test to write for the feature you're building, then that is definitely what should be written for that feature, no matter what. Okay, and then this is a question that I find teams do not ask themselves enough. So I will work with companies, bootcamp grads, and I will help coach them through essentially starting out the project. And very rarely at the beginning will testing be included because the cost of testing is high. And I think the reason why the cost of testing is high is because people are hesitant to practice and get good at it, and therefore think it's more expensive than manual testing. But if teams actually measured the amount of time that they spend testing the application manually per engineer, then those budgets would likely blow the actual test automation writing budgets out of the water. As far as I've seen. I mean, think about it. How much time have you spent testing? And does it give you confidence, or do you feel like, oh, I think it works? Right? That's a different feeling than, no, I'm sure this works. Right? So think about how much time you're spending manual testing, and the things that you're testing a lot manually we should be thinking about ways we can move those into our automated test strategy. Now, keep in mind that manual testing is a healthy part of any test strategy. We just want to move as much of the manual labor to automated tests as we can. Okay. Can someone tell me again? There, actually, it's kind of a hard question to ask, but because I think there are a lot. What are the benefits to automated testing for a team of more than two people, or a team of more than one people, I guess, per person? So a team of two or more. What is the benefits of writing automated tests?
I think the first benefit is that, like, when you write something, it has the same behavior when you do the testing.
Yeah, that's a great point, right? If we're manually testing, then it's up to each developer to talk to each other to figure out how each of them are testing this thing, because we want consistent tests. I don't want one person to spend 5 minutes and one person to spend 1 hour testing a feature. We get very varying levels of testing there, but they're testing the same thing, so that doesn't make any sense. I would rather those two people maybe meet somewhere in the middle and spend more like 15 minutes each on it, but do the same types of tests and be consistent on that. Okay, well, that's a lot of extra work. Why don't we spend that time writing automated tests that we know will be run the same for every developer every time? And we can have process in place that says every developer needs to run this set of tests. They don't need to choose which test they run. They can run this entire set of tests every time they commit to our master branch or something like that. So lots of different things we can integrate manual testing into, and then often trying to look at ways to reduce the cost of this. Okay, this book, that's my copy. Right? This is my copy on the screen as well. I took that photo because I couldn't find a good one. Great book on the subject. I'm not suggesting everyone here read it, but I actually included a few things in here because I do want to convince people that sometimes, and that's not all the time, but sometimes test-driven development is actually worth it. It's quite useful. I will use it myself because I might not be essentially sure what the requirements of my feature are or what my function potentially could do. So I'll write some tests first to try and figure that out, and then I'll make my code pass those tests. So that's test-driven development, right? If one changes a feature, we check that it doesn't affect other devs' work. So, okay, yeah. So that was, I think, a response to why we write automated tests. Exactly. We can change a feature, and if our test suite is quite thorough or thorough enough that it gives us confidence, and when we run that against it, we can be confident our code works. I think that's a great, exactly. So it's mainly two things. It's about consistency of the tests, and it's about, again, just a backstop to make sure we learn early that our code breaks or not. We don't want our user to be the ones to find it breaking. We need to do everything we can to be the finders of the breaking code. And that kind of really brings us here to this goal of clean code that works. This happens to be the first 4 words in the book. The preface of it starts with these words. And if I switch over here, I'll show you. I've shared inside the docs here. I actually transcribed the preface for this book, just so you could read it as well if you wanted to, because it's actually quite nice to read. I'm going to only skim past a lot of this stuff. Okay. But that's just in the notes under TDD, a markdown file here. Okay. So clean code that works is the goal. Does anyone not want to join me on that? Everyone wants clean code that works, right? I definitely do. Great goal. And so that's what test-driven development claims to give us. If we follow the rules. So these are the rules of test-driven development. Everyone's read them by now. So let's talk about them. The only way that I can write new code in my project, if I'm following these rules, is if a test is failing. That's the rule, right? I can't write new code in my project if a test doesn't fail. And so what that means is that in order to actually write code, I have to write a test that fails first. That's test-driven or test-first development. Now here, I put a little asterisk and said, the minimal code necessary to pass the test. Okay. So that means that we need to, I got an example here. So let's write a test. This test fails. It should add 2 numbers, 1 and 1 to be 2. It's going to fail because the function add doesn't exist, let's say, or it's not exported. So the first thing we might need to do is just make sure that function exists. And then we can write the minimal amount of code necessary to make, I saw a laugh. That's great. We should be laughing at this because this is ridiculous, right? No one would do this, but you should if you're following the rules. Okay. Now, why would I point that out? I mean, it's right down here. If I write this test instead, this code is no longer valid, right? So if I write a poor test like this, then I can write bad code like this and still make it pass. If I write a good test like this, and I'm saying it's good because it doesn't just check to see if it returns 2 or not, it also checks to see if when we add these numbers together, we get 7, and when we add these together, we get that negatives work, let's say, as well. Right? That's the kind of thing that we also want to be testing. So we would start off by saying, well, let's write this test. Okay, let's write the code, minimal code to make the test pass. Oh, that looks weird. Okay, maybe our test isn't as good as we thought it was. Let's fix the test, make the code, make it fail again, and then we can go and fix it to actually do what we want it to do. Okay, a very contrived example, but if we're not thinking in this way, then we will run into this problem where we write tests that could be cheated, essentially, if we wanted to do it that way. And that's not our goal. So that's why I'm warning you right now about this sort of a thing, right? So the second step is to eliminate duplication. And this is how it's just called refactoring. So minimal amount of code to make the test pass. That means not necessarily the minimal number of lines, but what you can do as a developer, what you know what to write to make the test pass. That's also important, right? Because I find with students or people new to the industry that there's generally 0 or 1 way to solve every problem, right? Does that anyone feel that? I don't know. But as you gain more experience, you start to uncover all these other ways to solve problems. So then it gets to a point where you might have 3 or 4 different ways to solve the same problem. Okay, so you need to choose one that you know, minimal, get it working, make the test pass, make sure the test is good, and then refactor to eliminate duplication. That's how our code becomes clean and it works at the same time. It's a process. Red, green, refactor. Red, the test fails. green, we make it pass. Refactor, we improve the quality. Okay, so it looks like this, a loop, right? Red, green, refactor, over and over and over. But this is the process that I really want us to be thinking about. It's progress forward. Right? That's what this process is about, is progress forward. And in the book, the metaphor that's used is like writing code is like pulling a bucket up a well with a crank. So that little bucket on the left there, if it's full of water, I could probably crank that thing until it comes up and not lose enough energy to have to stop, right? I'm probably strong enough to do that. But let's say we fill that bucket with tons of water. Now, I probably can do a couple cranks before I get tired. So what we need to do is add teeth to our wheel so that when I do a crank and I let it go, it stops and we never go back. Does that make sense, this analogy? These teeth are the tests that we write during test-driven development. By writing these tests, we keep moving forward. And if we keep running our tests, then we will know if we potentially would be going backwards. And so they provide this sort of stopper on our project to prevent going too far back. But again, read that intro to the book. See if you're interested in it, and just keep in mind that TDD is not all or nothing. Okay, I use it sometimes in some strategies. So, but I want to make sure everyone here is aware of how it works. And I'm going to try and write a few of the tests today first before I write the component. Whereas there's some components that we can implement or are already implemented that we'll write tests for after the fact. So it's a hybrid approach, as I call it. A hybrid approach to test-driven development. Okay. What is regression testing? Does anyone want to? I would love if someone could answer this question for me. It's okay if you don't know. Regression is regress is the opposite of to progress. So if we're not progressing, we're regressing, let's say. Or I guess we're standing still is also a possibility. We write regression tests to make sure that our software does not go backwards in quality. We want to make sure that bugs that we found already no longer exist in our project for the rest of its lifetime. So that means that we need to potentially write automated tests for every single bug that we find. So we run those automated tests. We identify any regression in our project before we actually commit the code. We don't want that regression to make it out into the wild. We don't want our users to see a regression in our project. So regression testing is testing that helps us prevent regression in our software. I'm going to switch over to the notes here, and I'm going to show you an article. Here we go, blog post. How to uncover a 0 day in 4 hours or less. This is brand new. And actually I read this article while I was preparing the lecture, and it was very relevant. And I thought that's fantastic when that happens. So at 3 p.m. on Monday, May 23rd, the Uncover jailbreak was released. Okay. So a 0 day is essentially a vulnerability that people don't necessarily know about existing in software. And so 0 day would be, it's been kept under wraps. Not been solved. The problem has not been fixed at this point. So these things are very valuable. You can see 0 day exploits going for hundreds of $1,000s on the dark market, in some cases, the dark web and whatnot. You can see people selling these exploits that no one knows about for 6 figures in some cases. It can be quite lucrative. So this researcher or developer, actually Project Zero team at Google. So that's interesting. This developer here talks about an experience they had finding issues in iOS 13.5. Okay. So I'm not going to go to the details about all of this actual exploits. That doesn't really matter for what we're talking about here. This is what matters. So there was a sock puppet. That's the name of the exploit. That's what they called the exploit, sock puppet. There's also an exploit called Lightspeed. And what they're saying is these exploits existed before in versions 12.4 and versions 13. And they're saying that the fact that these issues have now returned in a later release it suggests here that Apple did not run effective regression tests on these old bugs. They didn't test that their software would regress. Therefore, a security researcher found it instead, and they were able, they found the exploit instead. And if they had created automated tests that confirmed that these two issues no longer exist, and if they ran those against iOS 13.5, I think was the version, then likely they would have been warned early that these regressions existed, and they would have fixed them. They never would have gone out into the public. So here, this is the most important part of the article. Okay. Any questions about regression testing? We kind of understand why it's useful. Yeah. Okay. So every bug you find, write a test to make sure it doesn't return. And that's going to give you automated regression testing. Sounds like a lot of work. I worked at Electronic Arts for about 10 years, worked on a lot of different games. We had QA teams of hundreds of people, and they did manual regression testing. It meant that any QA tester who registered a bug, every week they would actually go and make sure that that bug did not still exist in the project. They'd go through back through all of their old bugs that had been confirmed as fixed and retest to make sure that they do not exist anymore. Very expensive. We made efforts to move as much to automated testing as possible, to write regression tests automatically as possible, to try and reduce the cost of manual testing, because it's not necessarily about reducing team sizes. It's about preventing testing team sizes from growing out of control. So we're going to learn, now we're going to focus on these tools. And that's really what you'll be working on today is writing tests with these tools. No one's going to ask you to put together a strategy. No one's going to ask you to write regression tests. It's mostly just about learning the different APIs for these tools. So the first tool we're talking about here is Jest. And this is going to be our test runner and general testing tool. I think no one's used Jest yet, other than in this project, right? How do people like the reporting and the experience? Is it okay? I mean, seems normal, right? Anyone with a dissenting opinion on that? Okay. Well, speak up if so. There's also these tools. The testing library suite. So React testing library, React's hooks testing library, the DOM testing library, and the library jest-dom, which doesn't actually end with testing library. There are more of these as well. And in our browser, we've got, this is the actual page for it. They've got all sorts of other libraries that included the Vue testing library. If I'm building a Vue application, I wouldn't use the React testing library. I would use the Vue testing library. And behind the scenes, both of those will use the DOM testing library, which is right here. So the DOM testing library is quite important, and it's going to be the basis for all UI testing when it comes to the testing library itself. All right. So here's kind of a breakdown of the different categories of things that we need to do and the tools that will help us do those things. So when we want to run tests and write tests and find the files with our tests, that is going to be what Jest does for us. It's going to look through our project for files that have the word .test.js or in a tests folder, and it's going to run those, include those in the running test. There's also this concept of matchers. Matchers are things like expect element to be true, or expect 1 + 1 to be 2. To be is a matcher. To have length. Expect array to have length. To have length is a matcher. That make sense? What matchers are? Okay, we've used them already, right? Yeah, good. So we'll get a bunch of matchers provided to us by Jest, And we'll also get matchers provided to us by jest-dom. Jest-dom is part of the testing library suite of tools. And those jest-dom are matchers that are specific for DOM elements. Things like expect element to be in the document, expect element to be disabled. Those are things we can do with jest-dom custom matchers, right? So jest doesn't include those because it doesn't care about the DOM. So we add another package called jest-dom to basically fill out our matcher library with more specific matchers. So that's going to help us out as well. The utilities are going to be things like queries, so finding elements in the DOM. How do I find the button I want to click? Another utility is how do I actually click on the thing? So I fire an event when I want to click on a button in the DOM. I've got so the octopus is the DOM testing library, and then we've got the React testing library, which is this goat here. That's the icon they use to represent themselves, and that is going to provide utilities that are specifically about mounting and rendering components. So you'll get a method called render from the React testing library. And with render, we give it a component to render. And that's how we actually test our components in React, is by using this extra library that knows how to render components for us. If we didn't have these utility libraries, we would have to write a bunch of code ourselves to do this, to do these things. So these are just abstractions around common things that we have to do when we're doing React testing. The last one here, sort of the horned goat, is the React hooks testing library, which also has utilities specific to testing React hooks. So things like I need to create hooks can only be rendered in functions, therefore or in components. Therefore, we have to provide an environment for that hook to be rendered in so it doesn't complain. And that's what React hooks testing library is providing to us, is again, just some utilities to make that easier on us. Any of the stuff in here, we could write ourselves. Let's just not do that. So mocking is going to be handled for us by Jest. And this is sort of this concept of being able to fake values in our tests. So we can isolate our tests by maybe removing a dependency on an API. I can fake the API response with a mock so that I don't need to run my API server during tests. And I can get a predictable return every time. We'll talk a little bit more in detail about that, but you'll write some mocks today, I believe, or tomorrow. I'd have to check because I think I'm not sure if the material got moved to the next day or not, but you'll write some mocks eventually for Axios, a full mock for Axios, where when you do axios.get, it will not do an HTTP request. It will resolve a promise to whatever you want it to. It's pretty great. It's kind of hard to think like, how should we mock this? What should we do? But practice makes that a bit more clear. And any questions that you have about that after the fact, I'd love to answer, because it is a bigger topic than we can fit in for today in its entirety. The last thing on my list here is coverage. And this is the idea that we can determine which lines of code in our project have been covered through tests by running the test, instrumenting our functions, and then getting a report back that we can look at and say, this function wasn't called, but this function was called. Inside of this function, this case was not hit because we never wrote a test that would actually fit this, actually trigger this condition. Only the else case is met. So we need to go write a test that also covers that other part that's missing. So we'll use coverage to help us guide our testing. Okay. So this is what a test runner looks like. That's the Jest test runner. When we want to write a test, we might group a bunch of tests into a describe block. Cool. This should be just review. If I want to skip a test, I have a couple options. Actually, I should mention here that I can use either test or it. I like to use it myself because I always start my tests with should, I think. And this is just a pattern I'd seen other people do. So I said, it should test something. Okay, good. Instead of test, and then I would say something should happen, maybe. Right? So how I write these tests, you could use it or test. Both are common. Up to you. If I use it, I can use exit to skip a test. But if I'm using test, I would have to use test.skip to skip the test. Just kind of a detail. This is all in the documentation. So once we start writing our tests, we can fill them in with assertions, right? I assert something to be true, and if it's not true, my test should fail. I expect 2 and 2 to be 4. This is the matcher would be 2b here. So we talked about that quickly already, and we're familiar with that. This is a list of the custom jest-dom matchers that I talked about, which we'll be focusing on using today. I highlighted a few that I think stick out as being quite valuable. We can kind of imagine how we might start to use these. If I can select an element in the DOM and I expect it to be visible, then I can check the to be visible, and it will look at it and say, is the attribute visible or not? Or maybe there's a few things that make components visible. For example, I can change the opacity of a component from 100 to 0, and I can also set visibility to be hidden. I can also set a color to be transparent. Do all of those, are any of those things, when are they visible? When are they considered invisible? So the to be visible matcher might consider a few of those things and try and make a good determination on that. I haven't actually looked at the implementation, so I don't know how far it goes on that. But there's probably a bit more complexity in that than just saying, is this attribute true or false for that one? Any questions about any of these? I haven't used them all, so I might not be able to answer it all, but cool. So all of these libraries, React, Vue, Angular testing libraries, are built on the DOM testing library. And what that means is that I only import the React testing library, and from that, I can also access all of the query methods that exist in the DOM testing library. So everything that comes from the DOM testing library is being re-exported by the React testing library. So you won't see me import at testing library / DOM in my project, but I still get to use all the functions that exist inside of it. Is that clear to people? Okay. Yeah, the layer we actually interact with is the React testing library, and it depends on the DOM testing library. And this is kind of how the different API that we get back. So when we're using the React testing library, it's actually a pretty limited API. It knows how to render a component. It knows how to clean up components after rendering. And it knows how to do this act thing, which is it's about asynchronous behavior. When we change the state in our component, when I click on a button or something, it might change the state of my component. I need to instruct the test to sort of wait and assume that test, that call that we're doing, that event that we're firing, is going to cause a change of state to the React components. So we want to wait for that render to happen or that update to happen before we continue down the tests. We don't want it just to check right away. We want it we want to actually trigger the state change. That's what ACT is for. We'll use it a little bit. I'm not sure we've seen it yet in our tests. That's why it's not highlighted there. The only one we've really, I think, used so far is render. When it comes to the DOM testing library, all of these we can access through our React testing library. It's got this combination of queries. So I can query by label text, by placeholder text, by text, alt text, title, display value, role, and test ID. There's different variants. I can get all, query all, find all. And I can combine these together to create 6 times 8 different, 6 times 8 different combinations of these queries, right? Query by title. Find all by display value. These are all valid queries. Does that make sense? How they've done this? They've taken a prefix and then combined it with their queries that they want us to use. These queries specifically were chosen because they are all queries that sort of act the way the user interacts with the site. When you're looking for an input field, if it has a label that says email, then we know it's an email input as users. We should write a test that looks for the input based on that email text that the user sees. So that's why we see specifically here a lot of, there's no get by class name. There's no get by ID. That makes sense? There is a get by test ID down here, and this is the only one that kind of breaks that rule, okay? And that's why it's down at the bottom, is because the last resort, we will apply a test ID to an element. That means your component, you'll give it a new attribute, or your your DOM element, like a div or a section or a UL, you'll actually apply test ID to it as an attribute. And that's going to let you select that element directly by test ID. Now, the reason why we use test ID instead of the word ID and just use the existing ID attribute is because we want test ID to actually be only used for testing, so that if it changes, it's only changing because of testing. Whereas an ID put on any HTML element could be changed for some other reason, breaking our tests. Okay. So if we can't use label text, that's the first one we want to try and do. It goes from top to bottom in terms of what we should try and use. And when we get to the bottom, okay, last resort, let's use a test ID. Does that kind of make sense? There's a guide actually on here. So if you go to recipes, let me switch over to this. Go to recipes, right at the top here. Which query should I use? So they've anticipated this as being a question. And here's the priority. Based on the guiding principles, which we know about now, we test in the way the user tests the page. So your test should resemble how the user interacts. We recommend this order of priority. So first, start with queries accessible to anyone. Actually, you know what? I think I may need to redo the slide to actually follow this order, because I just took it from their documentation, which now seems to be a little bit misaligned, right? This is the query list that I took, but what we really want to make sure we're doing is using their priority list here. We say first off, queries accessible to anyone. Anyone can see this. So get by role, label text, placeholder text, text and display value. Those are all good accessible ways to select things. Semantic queries. So this is a little bit different because no one sees necessarily the alt text. Users don't see the alt text of an image, but we know it to exist. So we can select an image or an area or input with alt text. But inputs, likely we probably want to try and do it by label text. And if our inputs don't have labels, well, then we need to ask ourselves, are we accessible or not? Could a screen reader, could someone use this site with a screen reader, for example? And the answer might be no. So that might be an indicator that we should start adding labels. And then also we can just use those in our tests after that. So this is actually part of their motivation, is that by doing this, we actually can encourage accessibility as well. Accessibility, sometimes referred to as A11Y. So you might see this sometimes, A11Y. And accessibility has 11 characters between the A and the Y. Does that make sense to people? Okay, what about this one? I18N. What does I18N mean? Anyone? I18N. Internationalization. So that would be, I'm providing another language for users. So not just English. I could switch between English and French and Farsi or whatever, right? There's lots of different options there. So you'll notice these types of codes around in web development. A11Y is a popular one. I18N is a popular one. A16Z. ZZ. I don't know. What's this one? It's not important to know. Andreessen Horowitz. I don't even know how to spell his name. Their names. It's a VC firm. And they went with it too. So I've seen here we go. A16Z podcast. So yeah, that's what that might be a way. So I was just talking about accessibility. I wanted to bring up that sometimes it'll be called A11Y, and you'll see that out there. All right. Getting close to the end of these here. Any questions about where this API or where it comes from? And this is important to know, because I think that's one of the most important and confusing things about all these tools, is just knowing where do we import stuff. So when it comes to mocking, here's an example of a basic mock. I can create a function, a jest function here. That's actually what we call a mock. And in that, I can actually run assertions on that mock function and use it to determine things about, for example, how many times was that function called? In this test, it doesn't get called. So I check to make sure it's called 0 times. But let's say that our code calls a function that we pass into it 3 times for some reason, right? When we pass it, we call a function, we pass it a callback, let's say. We want to make sure it calls that callback 3 times. Well, we could create a mock that represents that callback. We could pass that mock to our actual function that's running the code. And then when afterwards, when our function has run that code, we can check to see if that mock had actually been called the number of times we expected to or not. We can also check to see, expect mock to have been called with arguments, and then see whether or not it was called with specific arguments or not. That's another way we can do it. So mocking, that would actually be, I think, a term, the term used for that would be spying. So in Jest, I'm finding that mocks and spies are using the same API. So both mocks and spies will use jest.function to create basically an introspectable method that records when and how often and with what arguments it gets called. And that's what, and so the second thing we can do with mocking that you'll be doing today as well is providing a mock implementation for a module. So actually replacing how that module behaves. So mocking lets us do that as well. And I think I had one more thing. I'll come back to if I remember. We won't, again, like I said, we won't be able to go deep into mocking today. What we will, it's just an introduction. This is what code coverage looks like. I will run some code coverage today so that we can actually see that as we progress in our project. And I think for now, we're just going to open up for questions and then take a quick break before we move on to the live examples. I'm going to give you a minute or two to think about it. If you want to go, and if you really know there's no questions, absolutely go start the break now if you want. But think about it for a second. Take a
I
peek
got a
at the, yeah,
question
please.
directly related to testing.
Of course.
I saw your terminal over there, and I saw in another exercise I had to deal with yarn instead of npm.
Yes.
Yep.
I see
Like what's
here.
the difference between yarn and npm? Or
Okay.
Node?
Yeah. So npm has for a long time has been included with Node. When you install Node, you get npm as well. Early npm was not very good. Okay, so the npm you're using today is not the same npm that existed when Yarn was created. Does that make sense? All the features that you have today in npm, a lot of them are inspired by Yarn. So Facebook built, I think Facebook built Yarn because npm didn't solve its problems. It didn't actually give them the benefits that they needed. So they wrote Yarn and created a compatible module manager for Node. npm since then has definitely improved quite a bit, added a bunch of the same types of features. So I use npm because it is as good as Yarn is. I don't need to install Yarn separately. It's an addition that I would need to make. I don't have any problem with Yarn, but I would say if you have a project, choose Yarn or npm for the project, not for the developer. So as a group, either all use Yarn or all use npm, but don't try and use one and the other, because then you'll end up with 2 lock files: package lock.json, yarn.lock. Well, package lock didn't exist originally, but it got added. Yarn had a package lock because that's something they needed, which makes a lot of sense. There's just lots of reasons why people built Yarn, but I would say today there would be no reason to build Yarn, and that's probably why I don't use it. I don't know if Facebook has any, or I think it's Facebook. I don't know if they have any special features in Yarn that we don't get access to. Maybe it has special features that work with their internal infrastructure, because they might have their own package manager as well that's not npm. I mean, I would guarantee that they have their own internal package manager that they push packages to, that probably may not work with npm. Who knows? Maybe there's special things that Yarn does after installing. There's lots of stuff there, but yeah, if you see that, just one or the other. Cool.
Yeah. Thank you.
Sweet. Yeah. Any other questions? That's a good question. It is related to testing, I think. Well, it's related to what we're talking about today. And actually, when I saw it up there, I thought, I wonder if someone will ask about yarn. So I'm glad you did. Thank you. Okay. So obviously, there's time for questions later as well. Let's take that break, 5 or 10 minutes, and then come back and we'll start doing the live coding. I wonder how close we are to starting again. A few people missing. It's like about 7 or so. I know some people aren't using their cameras. I think a few people aren't. So I'm not sure. Okay, we've got 2 people left that don't have cameras on. I want to make sure. Okay, Trevor's here. Cool. Great. I think Andrew's there, just not showing. That's fine. And how about Ali? Yeah. Yeah, cool. Thanks, Ali. All right, let's get back into it. I've got my code set up here, and we're gonna see that all right. Okay. So this project, it's a React project. I created it using Create React App. It's got a bunch of components, it's a couple of hooks, some utils, and then everything gets loaded up right here for my application. I'm going to just show you this now because this is actually. I'm going to show you the project that we're working towards. Let's see, what did I do? Not npm install, right? Npm, yeah. Didn't even npm install yet. So I've just cloned this from my notes, gone into the project directory, and now I'm installing dependencies. And I will then start up the app. We'll be able to take a quick look. Should have done this already.
Carl, are you on Windows?
Today, yes.
Okay. Just a quick question for the command line or terminal on Windows. Does it take Linux command or is it like way different?
I'm using Windows or WSL2, so it's Ubuntu. If you notice at the top of my window here, it says Ubuntu 20.04. So my VS Code app has a remote session set up with the Ubuntu virtual machine running in my Windows environment, if that makes sense. So it is Ubuntu in the terminal right now, and I have another. I can probably try and share that as well. That doesn't seem to be showing up. What's going on there? Yeah, I haven't had try to show my. Oh, there it is. Okay. So this terminal is this is just my Windows terminal, but I can also create a Windows PowerShell prompt, a command prompt, Azure Cloud Shell, or Ubuntu, which is only after you install Ubuntu using the Windows Store. Then you can set up and enable WSL. You can start to use Ubuntu on Windows. It works pretty well. You'll notice here I made sure that this is a folder that is actually on my virtual machine rather than a folder on my Windows machine. And the reason for that is because I find things are quite slow if I try and run across this sort of machine boundary. So other than that, it works pretty well for me so far. And I was using Windows WSL 1 before, and they've improved it. It's much faster now. This is since the end of May. So anyone who hasn't updated, has Windows and hasn't updated since the end of May, then probably wants to get this WSL 2. I'll start up the project, and we're going to load it up in. Get rid of the terminal here. Okay, so we're going to notice first when I refresh this, it says loading because it's actually trying to load some data. That data happens to be these things here, the upgrades and their cost. And so what this is, it happens to be a clicker game. Has anyone seen a clicker game before? Has anyone not seen a clicker game before? You put your hand up. Okay, so some people haven't seen a clicker game before. Actually, I kind of like Paperclip Factory more than Cookie Clicker. So with Paperclip Factory, I go here, and I'm presented with my paperclip machine. I can click a button here, and I made a paperclip. When I make enough paperclips, I'm clicking. That's why it's called a clicker game. Oh man, this is frustrating. Why do I have to click 100 times? Okay. Don't worry, my example doesn't make you click 100 times. When I do that, I should be able to. Oh wait, I haven't made enough money yet. But what I'm doing is I'm generating these paper clips. They get sold, and then I can use the money to upgrade and create things that make new clips for me. And the goal is just to get this number as high as possible. I've beaten this game before. It took me about a day, but the whole interface changes. They've got. I don't want to ruin it. I will. Eventually, they get aliens. The aliens show up. So, interesting game, kind of cool. I didn't do it legitimately. I actually wrote some scripts and stuff that would click the button faster and help me out and not waste time and stuff. But I was just really curious about sort of every evolution of this game, and so I wanted to play through it. And so I also did it with Cookie Clicker. Cookie Clicker is a little bit closer to what we're doing right now because it doesn't have the concept of actual like money. You click on the cookie, and when you click on it, bake enough cookies, you can click over here and upgrade and use those cookies to, for example, buy a cursor that will automatically click every. Let's see, it says auto clicks every 10 seconds for me. So if I do this a bunch and I buy a bunch of these cursors, we can see my per second clicking is going up. I'm not pressing anything right now. And every 10 seconds, we should go up by 0.3 cookies, let's say, right? Make sense? Okay, these games are stupid, but it actually gives us some interesting stuff to work with, right? So we can say, I fixed 10 bugs. It's unlocked my console log. So now I've got an upgrade. And with that upgrade, I'm now fixing 1 bug per second automatically, let's say, right? And so now what I want to ultimately get is some help from Mentor or the documentation. So I just keep trying to upgrade. And we'll notice eventually I don't even have to press anything, and I get money to buy these things, right? So, right. And I can click this. And so we've got really 2 interactions changing the same state. There's every time a second goes past, it'll look at how many bugs per second we're fixing and increase the bugs by that. And every time we click the button, it'll take the current value and add 1 to it. That kind of makes sense how this works? Okay. So this is the game, and that's all there is to it. Okay, so if I go back to our code, I can also test this. I'll hit A to run all my tests. So by the end of the day, we should have, or by the end of the lecture, we should have 17 tests that we've written that we're actually using, okay? And those are all going to be contained inside of a test folder. For example, got these 4 test files here. We've got tests for hooks, and we've got tests for, we got mocks for utils. The tests for the utils, I've actually put them right next to the file, just to show that that's another way to do it. Let's go. So we've seen the test passing. The last thing I'm going to do is run a coverage report on this, just so you have an idea of the coverage that we're going to get by the end of this. So it has to run the test, and as it runs the test, it'll figure out how many lines of our code have been run. So it looks like most of these files are going to be tested thoroughly. All the lines of code, all the statements, all the branches, all the functions, all the lines will be run, except for the index file, which is really just this right here anyways. So maybe that's something you don't bother testing. I think that's okay to have some red in here. But for the most part, we're going to cover all the lines of code. And if I take a look at this here, I can actually switch that over to the browser. I can go and look and see that these components are all tested. 100% of the statements are run. If I go and actually look here, we can see that this line of code was actually run 19 times. That's because lots of tests are running it, and other tests that test other stuff might actually load the bug component. For application, we can see 85 times here on this loop. Kind of makes sense. So this tool is actually quite useful in order to tell us what is tested and what is not tested. If I go in here and look at index.js, it says this line, which happens to be one line, is not tested. We don't actually run any tests that make sure this works. Cool. All right. And actually, I'll just show you. While I was gone, fixed a lot of bugs. It just keeps going up. So I wish that was real. I wish we could actually do that. All right. So we won't really need to use the browser anymore to look at our application until it's done. Really, we could do all of this through testing if we want. And so that's what I'm going to try and do is write most of this without actually loading up the browser. But first, I'm going to check out a base branch. And what the base branch has is empty tests. And in some cases, missing implementations for those components. Right? So I'm going to start by thinking about these utilities, because I'm going to start by writing some unit tests. You've already done something very similar to this, but I want to now show you the same process applied here. So I actually have this code. I could TDD this, right? I could write these tests first and then write this function. I would say in this case, I won't do that. What I will do TDD for the bug tracker hook, and I will do TDD for both the bug and the status components, I think. And then I'll leave the rest of them. I think this one is actually, the implementation's here, so we just need to write a test for that. The implementation here also exists. It exists here, so we need a test for that. I think. Yeah, let's leave that in there. So here is that loading logic right now. When we render our component, an effect is created. That effect gets the upgrades, which is an asynchronous request. It doesn't actually make an API call. It's only a timer, but for our purposes, that doesn't matter, right? The difference between where the data comes from doesn't matter as long as this returns a promise and happens to be asynchronous. That's what we've simulated here. So get upgrades is really just set timeout after 3 seconds, but it's to simulate the idea of asynchronicity in our tests, because that's something you're going to have to deal with today for sure. Let's see. Oh yeah, it was application that was on. So when the application loads, it'll run this. When we set the upgrades, which are what come out of this, it resolves with an object that describes these upgrades. I think it's actually, yeah, here. It's an array of objects. This is something we could get from the API. And we feed this to our upgrades here. So we're saying these are the upgrades we use. And for each of them, we have a label, a cost, and the amount of bugs per second that once that upgrade is applied, that's what the bugs per how many bugs per second it helps us fix. We can yeah, okay. So this is where our configuration is coming from. Takes a little bit of time. When it's loaded, it sets loading to false, re-renders, checks to see if upgrades.loading is still false. It is not now. So it ends up returning and rendering the full app. It goes through each of those upgrades and creates an upgrade button for each one of them. So that's kind of how that asynchronous logic I've put in here works. This application uses 2 custom hooks, one to track the number of bugs fixed and one to manage the auto-fixing behavior. So I think custom hooks are quite useful, and otherwise this code, I would be putting it directly into my component, and it makes the application look a lot more complex than it really needs to. So that's one nice reason to use custom hooks that you build. And also custom hooks can be tested independently, as you'd seen during the project. Okay, I think, yeah, I'll start with just writing this test out here. So I've got this simple function. The function is pure. I pass in a value for the number of bugs, and it will return to me one of 4, or return one of 3 options. And if I give it a negative value, I want it to actually throw an error. Okay. So here I say I start formatting my tests. I group them all into a group that says these are all tests for that function called format current bugs. And the format current bugs function should return you have not fixed any bugs if the bug count is 0. So that test looks something like this. How many do we put in here? 0, right? If bugs is 0, then we expect to see you have not fixed any bugs. Okay, so I'm going to run these tests as I do this. And we're going to see this test pass. I guess these 3 tests are all passing because none of them have assertions. But this one is actually now running this code, because if I change it and I run, we're going to see that that test doesn't pass because it's expecting you have fixed any bugs, but it received the correct value, which was not. Okay. So that's one way you can check to see if your test is even working. Because you might write a test, like, oh, does it, is the test good? Is the code good? Who knows? Well, try and make the test break, and then try and decide after that if it is or not. If it doesn't seem like it's working, sometimes I'll just go force a break, take a look, and say, yeah, no, actually that is working the way I expect it to. And once we've written one test, it becomes pretty easy to continue to test things. Now, I'm not putting all of these into one test function. And the reason why is because I actually like this output. I like this output to be specific. Although you will see me put a couple expectations in some tests, you probably want to try and categorize and group things and be descriptive about them. Right? So here we're saying it's 1 bug, and it should say you have fixed 1 bug. And this is 2 bugs, and you have fixed, should say you have fixed 2 bugs. I run this. Oh, I forgot So there's going to be 2 types of breakages in your tests. Sometimes your test is going to fail, and sometimes your code is going to actually break. In this case, it was a syntax error in my test that caused the break. It wasn't actually the code running and breaking. So we need to recognize the difference between those things. I'll just save that, run it again. All these things are passing now. If I try and put a 3 in here, that should fail. All right. But I think this thing here, it's not that this is kind of like our previous example where I just said return true, right? So I could say in my code, I could say if bugs is equal to 2, return you have fixed 2 bugs, and then that would solve that problem. But what if I pass 3 or 4 or 5 or 6? So logically, the default is anything over 1. So in my test, I should probably also should return you have fixed n bugs where something like that, where I'm just being a bit more specific about it. And I'm saying here, this is 5. And it should say you have fixed 5 bugs because that happens to be what the value was passed in. And then I want it to also check to see if it fixes, or if this works. If cool. Let me see if I can actually find, now that I actually just thought about it, see if I can find I think that's it. No, I might have to actually go look my other lecture for that. So hmm. 142 kilobytes. Huh. Oh yeah. GitHub was acting really weird yesterday. There we go. So this would be the joke I was looking for. Let's see if it's in here. Oh no, maybe it's the other one. Yeah, it is. Yesterday, I had a hard time even loading anything on GitHub. They were having problems last night. Okay, here we go. There we go. That's the one I'm talking about. Make sense? What I'm trying to say here? As the tester, this is how a tester thinks. Whereas the way you think right now is, I will order a beer, and then if I get that beer, let's move on to the next piece of code, right? But pass in a lizard, give it a negative number, random characters. There's this thing called like fuzzy input or fuzzy, where you can write. There are tools that you can actually even just use that will just randomly throw words at inputs and see if it crashes it. Maybe random characters, maybe non-Unicode characters. Just throw in as much as we can at these inputs and try and break the thing. So that's kind of why I'm saying here we have to actually test more of this, right? Test. And so this test is kind of redundant now. I probably don't need that anymore. And actually, maybe I should have written this way in the first place. But I kind of just wanted to illustrate that to you, that it's very easy to make this work for that one value, and the test isn't actually thorough, even though coverage will report that that everything is covered. This is not a high quality test because we can actually write a function that passes this without actually working properly. Whereas this makes that harder. This type of a test makes it harder to write a function that works incorrectly. So that's good. The last thing that I haven't done So here, I will test that my function format current bugs when past oops. What is going on here? Okay, this will be negative. So here, it's not going to return a value, right? It's going to throw something. Problem is if I just do this, so let's say I expect that format current bugs will throw, and I run this, I actually get an issue here. I'm throwing the error when I run the test. It's not catching it, which means that the test fails because the error, not because it didn't match this condition. So when we're testing if an error is thrown or not, we can't just pass the result of the function. We have to actually create a new function that knows how to, that jest can call. When it calls this function, it will catch the error thrown by this here and no longer complain about the actual error itself. So when we're trying to test that something throws an error, we need to make sure we wrap it in a function so that jest has a chance to actually catch that error in the first place, rather than running, because otherwise what we're doing is we're actually running this code. We may as well just done this and just run the code right here. Okay, hit the error, and we never even got to the expectation. Does that make sense to everyone? Okay. So we'll keep moving along. So that's a pretty straightforward example. And I think for this, we can actually test that the error is specifically this one. So if I run this, it should pass. If I change this, it should fail because it doesn't match the error that's expected. So put that in there. I won't bother writing a test right now for format bugs per second. I think now that we've done one, that could be an exercise. If you wanted to practice, you can go do that. Totally up to you. We could move on now to one of these component tests and do a unit test for a component. Now, I find unit tests are quite useful for components that have no children. And actually, we'll do this one test driven. So we'll say we have this bug component, and the bug component is going to allow us to click a button. And when we click that button, it's going to call an on-click event handler for us. So the first thing we'll do is we'll just make sure that this component renders without crashing. So we want to render our bug component. So the render, can anyone tell me where that's coming from? This render function I'm calling right now? Pretty straightforward, I think. But that's what all those slides were about, right? Render comes from the React testing library. Fire event does not come from the React testing library. It comes from DOM testing library, but React testing library re-exports it. So that's why we have that there. We're importing React because we're using JSX. We have to import React if we're using any JSX in our file. And bug happens to be the component we're actually testing here. So let's see if I run this. Does it work or not? No, it doesn't work. And it says here, cannot find the module. So that's I got red. So now I can write code to make it go green, right? Okay. So cannot find module components bug from bug.test. So it's looking for this file components bug and it can't find it. So I'll go and I'll add bug.js. I'll import React because I need that, and I'll export a default component, let's say minimum amount of code to make the test pass, right? Okay, getting closer. This is having trouble because it's actually trying to run the application test, but I don't really want to worry about that right now. I want to run, I actually only want to run a specific file. So when I test now, I have to actually think about that a little bit and say, okay, it's running all of these. My application is going to fail because that's where we're going to write our integration tests. And the application will integrate with the bug and the status and the upgrades and all that stuff and create the actual application. But we'll write those tests later. So right now, I just want to skip these. I'm going to filter here by a file name, let's say. So now if I say P and I go and I do bug.test.js, now it's only going to run that file for me. So application won't fail. It's rendering without crashing. Good, right? Okay. So this test here, technically passing. But now we have to think about, like, what does this component actually do? Well, it says it should call our click handler. So what we should do is be able to pass it a click handler. Something like, right? And when we do that, and then we can try that out and see if that works. Okay, that still renders. We haven't gotten a red test yet, so we can't go and change our component to actually handle this on click yet. We need to think about what happens. How do we actually trigger this click? Because we need the code to trigger the click. We need the test to trigger the click so we can actually see what function's called when that button is clicked. So here's where we'll actually take elements returned to us through render, something like get by text. So I think, again, that should be familiar now that we've gone over variants and queries, or queries are built up of these variants with the types of selectors we want to use. We're going to use get by text right now, and I'm going to search for the text that I expect to find on that button. So what text do you think we should label our button with? Maybe just, I don't know, fix bug or something like that. Okay, so here we'll say expect so it fails here now. And it says it cannot find an element with the text fix bug. This could be because the text is broken in multiple pieces. So that's actually something that happens sometimes is there might be some sort of a character between in that text that we don't see, but it's broken up into different elements. Maybe there's spans around it. So so for example, like code on a website, we look at syntax highlighted code. There are hundreds of spans in there. For every keyword is wrapped in a span tag, so we can apply a color to it, and every function is wrapped in a span tag, so we can apply a color to it. So that's what they're talking about here, is that we might look for text that's split between multiple tags. We can actually use an advanced feature to resolve that, but we know that's not the problem. We can actually see the entire DOM right here when this fails. And we can see that there is nothing in here, no button with the word fix bug in it. Right. So maybe maybe to get it to work, I don't worry about it being a button yet, and I run that and I add fix bug, and now it passes because it finds a div with fix bug. Okay. So I'll keep going and I'll say, I know that thing is there now. Let's fire an event called click. And let's get by text, find that thing, the bug, and click it. And then what we'll do is we should see the console log when that happens, right? Let's see. Oh, right, we haven't implemented that yet. So we haven't actually added the on click yet, so we won't see this console log. We are now firing a click for get text. We're not getting an error for this, but that's okay because divs can also have on clicks. So sometimes this will happen where you're kind of like, okay, well, I'm not getting the fail. I know I've done things wrong. I think it's okay here to just try and expedite a little bit and say, I'm going to make that a button. It's going to be clickable. I'm going to take in some props. And this is going to provide, this is actually an on-click, sorry. I'm destructuring immediately an on-click right here. Does anybody have a question about this syntax here? This component received props. Props.onClick can be destructured out of that props object. So I can say onClick is equal to onClick here. Now we actually see that console log output. But there's no way for us to like expect the console to have a message console logged. Maybe there is, I've just never done it that way. Instead, what we want to do is we want to have something built into our testing system that allows us to determine whether or not this function got called or not. And that's where we use a mock. So here, onClick is jest.function, which is a mock. I pass that mock now here to my click handler, and I expect that my onClick function to be called times 1. So now when I run this test, now if I put 2 here, we can see it fail because it expected 2 calls, but it only got 1. And that was this call right here when we click on the thing. So this is why this is the spy feature of mocking that I talked about earlier. This is why it can be very useful. And actually, this is very similar to our actions in Storybook. Right? With Storybook, actions provide to us a kind of like a filler function that knows how to output information into the Storybook console. And so instead of having to write our own functions that do something, we don't need to do that. This component only needs an onClick button function. As long as that gets called, this component is doing its entire job. And whatever happens inside of that callback, that's the responsibility of the component that actually uses bug, not bug itself. So all we need to do here is make sure that when this button is clicked, it calls this function. Then this component is tested, because that's how limited it is. Oh, put this back here. It is not called with any arguments, so I'm going to just forget about that. But often I'll also do something like on add to, or let's say on save, because this is actually a scheduler thing, to be called with Susan. This would be how I could test to see whether or not my form save button called the onSave function with the student, or let's say, I think it was actually ID and interview, right? It was like appointment ID and then an object that represents the interview, which is student and interviewer. So this is kind of how I would use the to be called with arguments. I would check stuff out like that. Cool. Okay. So we've just, essentially done test-driven development. We started by writing a test, and then we wrote a component that would satisfy those requirements. But that isn't required all the time. And I would argue that this component is too easy to do it that way, right? It's going to feel too easy. So don't force yourself. I forced myself, and you saw what happened. It's like, no, I should just do it, right? But sometimes I will write the test first, and I will write the function, and I will say I couldn't have done that at that level, at that speed, that way, without writing those tests first, because it really made me think about all the edge cases. And I could write that into my initial design and then refactor a whole bunch of duplication out. That works in some cases. So I still want you to think about those opportunities. But situations like this, it's obvious that there's lots of text that I kind of have missed here, and I want to make sure nothing here is. I hope someone would speak up if I missed something in the chat that was super relevant. Nice. Yeah, okay. The cookie clicker hacks. That's what we were talking about there. Nice. Okay. We could also write a test for this status thing. So if you notice, there was a component that would render out both the current number of bugs fixed and how many bugs per second the system would fix. So same kind of deal here. I want to render my status. And this is where I kind of think about, what is the interface for my component? what does my status component care about that it needs to report? I don't know if the app is still running. Let's see. So this is all, if I bring up my inspector here, oops. No, don't reload. Stop. Okay. If I bring up my inspector and I look at the, oh, that's embarrassing. I haven't installed the tools for this profile. I promise you I have them installed for my own profile that I use, but this is my demo profile, so I haven't installed them yet. But I will tell you right now, this here is the status component, and it's built up of a section. Well, that bigger. It's built of a section that takes an H2 and an H3, and then outputs this data here. So really what we need, the changing values, are the number of bugs that have been fixed and the number of bugs that are fixed per second. That's what this component needs access to. Oh, I'm not sure. I should have changed that over. My bad. There you go. This is all status. This is the section. This is the H2 and the H3. And the data that changes is here and here. So normally you don't have it built before you look at this, but I could look at a mock-up. Like someone gives me a mock-up of this interface and I have to show a status window or a bar. Then I would look at that mock-up and I would say, what are the variable things and what are the constant things? And those variable things, where does that data come from? When it comes to my application itself, I can pass those props in here. I can say that the bugs is, 12, because right now we're just doing a test, whereas normally this would come from the application. It would be stored as state. But right now we're just doing a test. So we need bugs and BPS to equal. Yeah, bugs and BPS is ultimately what I ended up using. So bugs and BPS. And the status says, okay, well, we fixed 12 bugs and we currently are at 2 bugs per second fixed. I'll probably need to find that text to see if it says expect say, if I'm doing test-driven development, this is where I decide what the user interface says if I've not been given a mock-up. So I might have to make some decisions here about what my interface is actually going to do. But in my case, someone actually gave me this mock-up. So I will just use whatever they said here. So you have fixed, that's the text that we're using. There. And the other thing happens to be this fixing per second. So we'll put that as well. And I'm just going to switch this now. So we expect that this text exists in the document. And the reason why we expect this to exist in the document is because when I pass in the number 12 here, it should construct this message using my format function. I've fully tested my format function, right? Like I feel pretty confident that these unit tests here test all these different edge cases for this one function. So I don't need to actually do all those tests here as well. I don't need to test that the status shows all those things under all those circumstances. I just need to show that when I render this component, this message is correctly displayed in the browser. That's all I really care about for this test specifically. Because whereas if I didn't have this unit test down here, well, then I probably would have to do a bunch of that testing up here in the status test instead. But it's harder to do in here than it is in the other file, right? I mean, a little bit harder. I got to render a component first, and then I have to check to see if that element is in the DOM. Whereas With this, all I do is call the function, which is what we're all currently familiar with. That might be the difference there. So that's why I believe these tests should be unit tests in my utils folder, and then anything that uses them should only really test the specifics of that there, right? Of this component, or sorry, this status component. So we also want to check to see if this one's in the document, and if those are both in the document, then I'm pretty happy with the status component properly rendering out the text. Now I'm curious, if I npm start here, what kind of an error will I get? We'll see. Okay, so it's still not working. Cannot find, oh, I see. Can't find these hooks, can't find files still. So I still need to go and build those features to get this stuff to work. But component status, oh, I haven't written that file yet. That's what's happening. Okay. So I'm going to just grab this, paste it, change the name. What are my props for status? Anyone?
Bug and BPS.
Thank you. Bugs and BPS. I may have done the layout for this already. So what I'll do is I will return a section that has an H2 and an H3 here. I can import my format functions. Let's say, actually I forget what the second was called. Maybe it'll help me out if I tell it where I want to import from. There we go. Now I get bugs per second as well. And I'll take this and use those here, knowing that they work quite well already because my other unit tests. And good. This is still failing because it's the application test, which is an integration test. Excuse me. Doesn't exist. So, or the file it uses doesn't exist. So we're going to go back to our npm test. We're going to run all these. It's probably going to fail on this last one. So we will just quickly filter status. And that passes now. Cool. Okay. So we've written a couple of tests, and then we wrote some components that satisfied those tests. I think most of the time you'll probably write the component first and write the test after. I hope that's the case. I hope it's not just ignoring tests after. But let's talk about some more, maybe a bit more complicated tests. So we got this bug tracker here, and there's two things I want to test. One, that when I click, or that when I call essentially an increment function or add bug function on the use tracker hook, it should increase the stored bug count. And if I call remove bug or decrease, it should call or should reduce the bug count. So something inside of this bug tracker is going to need to keep track of how many bugs are currently shown. And that's the data that we end up seeing in that status bar eventually. So for the bug tracker, I'm going to create a use bug tracker hook. This is going to return, or let's say export this. And now I get to choose the interface for this. When I return, it should return bugs, maybe an add bug and remove bug function. This is just for bug tracking, right? So again, this logic could very easily go into my component, my application, and I could say const bugs set bugs equals use state 0. Just default to 0 bugs at the beginning. And then I could, when I let's say decrease the bugs or increase the BPS or whatever, I could, or add a bug, I could set the state to bugs +1. I'm just moving all of that logic into this hook instead. It's the same thing that would go into my component though otherwise. We'll default to 0 bugs. I need a function that knows how to add bugs. And we'll say a certain bug count. We can actually use add bug to add and give it a count, and it'll add that many for us. Because when we have the timer going, we want to be able to add 10 or 12 or 15 per second. Whereas when we click on the button, we only want to add 1. So we're going to say this just increases by bugs plus 1. Let's say count. Cool. And then remove bug, very similar, actually. Now what I want to do is make my test work. So I'm pressing W to get more options for watching. And I'm going to say now I'm going to filter based on the bug tracker test. So I don't have any tests written for this yet. It's not actually running any tests. That's why they're both passing. But I think this should work. So let me try it out. Let me go write a test for it now. The bug tracker is here. So when it comes to using our testing hooks, we need to render a hook specifically in a component, and that's what the render hook call does. So we'll say, and this hook, I believe we have to pass it. Actually, let me just double check this because it's been. So the question I have right now when I'm doing this, and I can't quite remember off the top of my head, but I can actually, I'll go look at the documentation, is do I pass it a hook or do I pass it a function that can call a hook? I think it's just, I think I have to do it this way because we can't render hooks outside of components. So this thing is going to be the component we're rendering the hook in. And I'm going to try that first. I'm going to say use bug tracker. So we'll render that. And this should return to us a result. And I think we can actually see that result on console on result.current. So let's see if this outputs that. We're getting undefined right now. Okay, so that's interesting. Let's see if this is it. Okay, that's better, I think. But now we just need to add some imports here. Okay, here's what I was expecting to get. Invalid hook call. Hooks can only be called inside the body of a function component. So back to this, I think. Better, okay. So it was failing because it didn't import the right library, which meant the module was broken. So now when we actually render the hook, or no, actually, sorry, we get undefined still. This is curious to me because I think, so let's go to, let's double check so I don't spend any more time on it. Oh, I see. Okay. Okay, that's the mistake I made. So just so you can see what I'm looking at here, this is just in the notes directly. So in the repo where this is all finished, I just took a quick look. And what we're doing here is we're rendering the hook inside a component. That was important, but it was actually destructuring the result. I didn't destructure the result, and result.current was correct. But this is actually, we're going to use act because it's going to change the state of the hook. So I'll go back and actually fix that. So this is destructured out of here. Now result.current, 0 bugs, a function, and another function. When I say act here, so this is just wrapping it up so that the tester can handle the fact that there's actually an asynchronous state change happening here. We can say result.current.add bug, which is, we know that this function exists, right? It just got passed here. So what we're end up doing is in the act, we're calling this function. We expect that to cause a state change, and then we want expect result current.bugs to be 1, let's say. Oh, add bug 1 here, sorry. Add bug 1. And then we could try this again. And we could say, well, we're going to add 10 now. And we expect after that happens for this to be 11. I feel pretty good about that working, at least for the adding. If I go and I change this, just because I'm not entirely sure, maybe I'm not confident in my tests themselves. Well, no, that works. Good. Exactly how I wanted it to. Okay. And so very similar. This is one of the beauties of testing is that I can take all this and really reuse a lot of it in my next test. I'm going to get rid of these console logs because we don't want to leave those in. Okay. I'm going to start off with 11 bugs. I'm going to remove a bug, and now I expect there to be 10 bugs. And then I'm going to remove bug 10, and I expect there to be 0. Oh. Okay, so this is failing now. Right? Now, that's interesting because I actually expected that to. Did I do that? Did I just do the math wrong? Is that? Oh, wait, I see. I know what the problem is. I never used my initial here. No, wait, actually, no. Yeah, I never made it so you could set the initial. That's what it is. I never made it so I could set the initial. It always starts at 0. So I actually have to consider that in my test and say, add a bug, because you can't remove if you haven't added. And actually, to take this even further, I think you'd probably write logic that if you tried to remove and there was 0 bugs already, it wouldn't remove anymore, and you'd write tests for that as well. But here we'll add 10 bugs or 11 bugs. We expect it to be 11. We'll remove 10 bugs. We expect it to be 1, and that might give us confidence that this works now. That's passing. Okay. And so that was, sometimes I might need to call this other API to put it into a state I want it to be in, and then I can call the one I really want, which is the remove, and test that, and then confirm it acts that way. Okay. So now I'm going to run this again because we've now got it running in the browser. We've implemented the files that we needed for that. If I click this, I actually get that behavior. The status is updating. I wrote that component separate from the hook, but they work together. The upgrades were already implemented, so that's why they're working. We're getting close to the end here. I'm sorry it's going over. Never know with new lectures how long they're going to take. We also now want to write a few more tests. One of them might be for this upgrades thing here. So my upgrades is actually kind of an interesting pattern I'm using. I don't know if anyone's ever seen something like this before. No. So what's kind of cool with React is that the children we pass to other components, we can manipulate them, essentially clone them, and replace props inside of them one time rather than having to do it for every single component. So what that means is in my upgrade tests, I have to make sure I have these two components, upgrades and upgrade. And I want to make sure that it renders, that the children are rendered, that uh, that these buttons are rendered in the upgrades list. That's what I want to confirm, that when I create an upgrade list and I pass it an upgrade child, it shows a console log 10 button or whatever text we want to configure that with. So we'll start off by render. We'll start rendering upgrades, and we'll pass it a single upgrade button or list item. So this is child composition, a child composition pattern, where upgrades can accept upgrade children. Normally, what we might have to do is pass the upgrade how many bugs it has. The reason why is because it costs it. We need to know whether or not we're going to disable that button. If we don't have enough bugs to buy that upgrade, then that button should not be enabled. So in order for that button to figure out whether or not it should enable itself, we'd have to pass the number of bugs down into it. So let's say you have 10 bugs. Okay. But because we've actually created this pattern here where when an upgrade is passed to this upgrades component, it actually needs label, cost, disabled, and on upgrade. And when we create the actual upgrade component, we create a new disabled prop on it where we grab the value of bugs that's actually passed into upgrades and we check to see whether or not that's less than what this upgrade costs. I know this might be a bit confusing. You might need to review it later, but let me show you what it actually looks like in here. I pass bugs one time, not to every single upgrade here. And I can also pass a couple of these common functions that all the upgrades need to use, which is decrease bugs and increase BPS. Those are functions that each of the upgrades would have to call every time we click one of them. When I click on console log 10, I want it to decrease the bugs by 10 because I just spent 10 on it. And I want to increase the bugs per second by 1 because that's what console log gives us. So that's what these two functions are doing. But in the end, inside of the upgrade, all we do is call the on upgrade function to do these two things at the same time. So this is about trying to figure out where this data is available for all these components and trying to make it so that we don't have to repeat this for every single thing. So when we talk about prop drilling and that being annoying, this is one way to avoid it. Now let's go and actually. So this is increase or decrease bugs and increase BPS. So now all these upgrades, when we click on them, we'll have access to that on upgrade, which uses these two functions passed in. The only thing we actually have to pass to the upgrade itself is, I think, just the cost and the label. Or no, wait, the label, the cost, and the BPS is what we need to pass into each upgrade. So here we'll say label equals console.log, or maybe we'll say the label for this one is just called increment. And I know that they have, increment, and the cost is going to be 10, and the BPS is going to be 1. So that's kind of like a console log upgrade. So does it render its children? What we need to do, or how would we determine that if I ran this code, it would actually render its children, that this actually gets rendered? How do I confirm that when I look at my app? How do I confirm that this is actually being rendered here? Okay, well, let's take a look at our DOM at this point. I want to see what the DOM looks like after I render this component, okay? I can receive a debug function, which actually happens to be deprecated in newer versions, but the version we're using of the React testing library should still allow us to access debug from here. I think they've switched it to screen.debug now, but that's just in future releases or in the current release. For now, I think we can just, the older way to do it is with this debug call. Oh, right. These need to be full now. I need to pass them something because they're saying that what this error says, syntax error, JSX attributes must only be assigned a non-empty expression. So that now I'm giving them functions that don't do anything for now.
Oh, we're currently looking at the browser, I think.
Oh yeah, of course. Yeah, I gotta get better at switching between those. Yeah. So the error that I was getting said that I can't pass in empty values as our attributes in JSX. So I had to fill in these empty things. And right now I'm just passing them empty functions that don't do anything. That's to get rid of that error. But now we can see that this is the output of rendering that upgrade and its child. And here we can see there's a button with the word increment and the value 10, the cost 10. So what we would do is get by text, and all we need to at this point is just expect get by text increment 10 to be in the document. Okay, and I'm going to just filter out only the upgrades ones for now. Cool. So that's now passing, and it confirms that it renders a child. If I wanted to, I could add more of these as well, right? I could say, I mean, I could use anything I want in here. This is only test data, so it has nothing to do with what our application actually shows. Right? So I could put console log, I could put development tools, or I could put pretty much any text here as long as that's what I actually end up looking for down here. And that proves that these labels are actually being applied properly. Right? Maybe this is 20. Whatever. And we could check to see if the other one was also there. Cool. Now, this is where it actually, the logic within the component needs to be tested. And that's where we're saying, we'll render all this. Actually, I'll remove the debug. We'll render all this. And now I want to be able to fire an event.click. And I want to get by text increment 10. Now, the key for this, let's say that my bug count currently is 2. I expect this upgrade button to be disabled because I don't have enough bugs for this cost. So that's kind of something that needs to be set up here, is that if I'm going to be able to click on this button and buy this upgrade, I need to make sure that it knows I have enough bugs to do it. And that's where this gets configured, right? And when it's actually in the application and not just being looked at as just an upgrade component, then this just happens to be the bug state. So whatever the current count is at that time. But when we're running tests, we don't have that state. We can just use a static value here. And when we click on this button, we can expect, now, hold on. Let's see. We need these two functions to be mocked or spied on. We need to spy on these two functions so that we know when it decreases the bugs and we know when it increases the BPS. So we'll create our mock here. Oops. We'll pass those mocks now instead of these useless empty functions. And then when we fire that, what we'll do is we'll expect that decrease bugs to be called times 1. increase BPS will also be called times 1. Good. If I'm ever unsure of what matchers I have available to me, I'm going to switch over to the browser. And I'm going to go take a look at the jest documentation. And I'm going to go look at the matchers. And I've actually provided this link down here to the reference. To have been last called with, or to have been called with. I think that's what we want, to have been called with. Switch over. To have been. And the value that we expect decrease bugs to be called with if we click on increment with the cost of 10 is actually 10. We hope that that function gets called with the value 10. And then we also want, oh, and I have to fix that I there. We also want to test that this function here, the decrease, I think, increase BPS, is going to be called with the value 1 in this case. Okay, it's looking pretty good. The thing was working already. We looked in the browser and we saw it working. We clicked on the buttons, it decreased, it increased, that all worked. This is going to allow us to test that without having to open the browser, so that we can confirm that if anyone adds upgrades or changes the way this logic works, they will be informed if this stops working at that point. So anything I go into my upgrades, and if I say here, oops, no, it's broken. Someone changed the code, it broke the code. It's no longer receiving that call because it doesn't call the function in the actual implementation. So that's how it protects us, right? Is that as soon as we make that change, run the test, we get to see that we actually broke something that worked before. Okay. So the last thing I think I wanted to do here, yeah, I don't think we'll have time for both of these, so I'm going to focus on the application. And when it comes to the other implementation, I'll just show that to you quickly. So the auto fixer, for anyone who's interested, uses an interesting pattern. We want to make sure that every second the bug count increases by the bugs per second. So we're creating a timeout that gets called every 1,000 milliseconds. It will call this callback here, which just increments the BPS. And that's what's actually going to, that's passed into this autofix function. So because, yeah, here, I'll show you in the application. Here, use bug tracker will tell us how many bugs we have currently. Autofix needs to know how to add a bug itself. So I take the add bug function that comes out of this hook and I provide it to this other hook so that autofix can call add bug with the number of bugs per second every second. So it's normal to pass arguments that come from one hook into another hook if you feel like, if it makes sense. Here, what comes out of it is BPS and the ability to add BPS. Notice that we don't have any ability to reduce the BPS with our game currently, but if we could reduce the BPS, then we'd probably add that to this as well. Because the actual state for what the current auto-fixing count is exists right here inside of the hook itself. Okay. Yeah, so anyone who wants to talk about this hook in detail after, I'd be happy to, because it uses some stuff we haven't seen yet. And that's why I've kind of left it out of the detailed explanation. It's using, yeah, mainly the refs is the mainly the new thing. A ref is similar to state, except changing in the sense that it will retain a value across renders. The difference is that if I change a ref, it does not actually re-render the component. So it's another way for us to keep track of something that's not state and that will not cause the component re-render. Now, we wouldn't use this for a lot for things that make more sense as state. For example, we want our state to change every time we render this, right? But when we're creating a permanent callback, let's say, or a permanent ref to an event handler, well, this is never really going to change anyways. We only set it once. So using a ref for that makes more sense. Okay. Let's not worry too much about that. Let's think about writing an integration test for this application. Because by writing an integration test, we're also going to be able to kind of see whether or not the auto fix works at the same time. And actually, let's do a quick coverage report just to see. And I'll just open it for you so you'll be able to see it. Cool. We're getting kind of closer, right? We can kind of see this is the status we have now in our components. Application.js is not very well tested. We can see that the only code that it actually runs is well, it looks to be one time this file gets imported. That's what that means, is that this file is imported in one test. Therefore, it calls the function that creates the component, but it doesn't actually even run the internal code because we never actually render the application component. Okay. All these are 100% covered. We can see, yeah, pretty straightforward. The hooks themselves, we've got all the tests for bug tracker. We added those so we can see all this code is being called, both the add and the remove are being covered. We don't have any tests for autofix right now. Those are included in the notes. So if you want to take a look at those after, no problem. And then we knowingly have left out some tests for the format bugs per second, let's say. Although this does get called. When does this get called? Why is this actually... Because the test that we do write depends on this. A test that we wrote for status calls this function. Therefore, this function is technically being tested as well. And so one of the cool things about coverage is even though we don't have a test specifically for that function, we can go and see that it's being covered somewhat right now, that this if path was not taken, this path wasn't taken, but it has said it works for this at least. It's tested that part out. As I roll over here, it's very hard to see, but the help by my cursor says if path not taken. It means that nothing passed in 1, 0, or -1 into this function to test it. The only thing that was passed into this was a number greater than 1. So if we wanted to test this thoroughly, we either add another test to our status and just kind of duplicate it that way, or add specific tests that test these edge cases as well. Okay. So we want to focus on right now the application. So the first thing to do is just get it rendering. So before, when we rendered something, this worked just fine. Take application, render it out, and I'm going to run my test now and see what happens. I guess I should probably filter. Okay, I promise that at least one of you will run into this red. So an update inside of application was not wrapped in act. So what that's telling me is that the application component set state without any user interaction. Does that make sense to everyone? That the application component currently sets state without any user interaction? When does that happen?
On line 20, when it first renders?
Exactly. Yeah. So, well, when it first renders, it creates this effect. It finishes rendering, and it shows a loading text, right? So we could expect get by text loading to be in the document at this point. That'd be okay. But then when that effect actually runs, it calls set upgrade, which causes a change to the component, but we've never indicated that we were going to make that change in the first place. And our test finishes, and it doesn't wait for the loading to complete. Okay. So anytime we make a state change and the component is unmounted, React will warn us about that. And that's kind of what's happening here is React realized, well, we ran the test, we mounted the component, we stopped the test, we unmounted the component. And now when the API request comes back 3 seconds later, it's trying to set state on something that doesn't exist anymore. So this is where we have to actually build asynchronicity into our test. We have to make sure that when we render the application, we also have a way to make sure the test can wait until that first initial state change is complete. So we're going to make sure that this is an asynchronous function. I know you haven't seen this yet. You're going to be introduced to async await for pretty much the first time today. There's a little bit in the notes about this, but I could write it as a promise if I did a return at the end. I could say, wait for element to be removed, tell it which one, and actually here I think I need to pass it a callback function so it can keep checking over and over and over. If I don't pass it a callback function, then I only give it the loading element once, but by giving it a function here, it can call this over and over and over and get the latest thing, see if it's found or not. Because if I called this right now, it wouldn't be found, but eventually it's going to come back and be found. Okay. So if I return, if I do this, I should no longer have that red error because now the test knows that I'm actually going to do something and I'm waiting for that thing before it shuts the test down. Cool? Okay. So this is returning a promise. But if we make this an async function, which by default or like by rule, every function that is marked async actually returns a promise. Let me repeat that. Every function that has the word async in front of it returns a promise. So we don't actually have to return this explicitly. We can say, we'll wait for this. And if that's the case, when we run this, it will also handle this promise, wait for it to happen. And then this whole function will not finish until all of the asynchronous things have completed inside of there. Okay. And if I want to, I can debug before and after. So here's before. And this is after. So when you I think when you run your tests, because it's been a little while since you last ran your application test file, and since then you've added an Axios request into the initialization of your application, then when you run your should render without crashing test where it only mounts the application, I assume you will probably get that red error as well. Cool? Okay. This is going to be our integration test here. This thing is it's going to be it's going to seem like it's pretty big, but it's going to just be a lot of repeated stuff because what we're going to try and do is test that it loads. And then once it's loaded, well, we've tested that it loads, but once it's loaded, we're gonna want to be able to click on the add bug button 10 times and confirm that it's increasing the count as we do that. And then we're going to, by an upgrade, we're going to confirm that the bug count has gone down in the status that we see. And we're going to confirm that after a second, the increase has started automatically. So all that stuff is going to happen inside this one application test that we're going to write. For this to work, though, we're talking about timing. We're talking about timers. Every second, something's going to get triggered. So we need to mock the timers so we can control timers in our tests. And Jest provides functionality called timer mocks that allow us to do that. Okay, so now if I do a set interval or a set timeout, Jest is going to mock that for me. It's not going to actually run after a second. It will run after I call the run all timers function in my test. So I'm actually going to manually manage the advancing of the timer while I'm writing my test at the same time. So I have to start off by telling Jest this test uses fake timers. I can just render my application like I do already. So I'll get rid of these debugs and just render my application. And with my application, what I want to do is I could do this. I could wait for this to be removed, but because I'm trying to teach something here, the opposite of wait for element to be removed or wait for element to be removed is to find to look for something that's not yet on the screen. So one of the things that's not yet on the screen is like the text, you have not fixed any bugs. That's what we expect to see first after it loads. So yes, we can do wait for element to be removed, and that actually makes a lot of sense when it's a loading indicator. And we can also wait for elements to show up if they don't initially. Make sense? In the latest versions of the DOM testing library, it's actually not wait for element, it's wait for. And if we look at the documentation, they will say that wait for element is deprecated, but you're still using an older version of this library, so it's okay. There are alternatives that have been updated. So if you start a new project and you install the latest version of the React testing library, it'll have slightly different syntax. But this library is changing and keeping the material up to date with it as it changes. We have to do that a bit more sparingly. So I think we will eventually update that, but for now, just keep in mind that there are versions of these libraries and you're using an older one, so the docs might not be exactly the way that it works for you. But you can usually go to a GitHub profile, go to a tag for an older release, and look at the older documentation, because all the documentation is versioned along with all of the code. So if I want to go make sure I'm looking at documentation for the version of the library I'm actually using. And I want to confirm that as I'm doing that. Okay. I've actually had people install a library before, and this is after boot camp and they're working on their own projects. They've installed a library and they said, this thing isn't working the way I expect it to. And they send me the documentation. And it turns out that the library that they installed is not the same library that they're reading the documentation for, even though they share the same name essentially. So careful about those things and try and be sure that as you're reading documentation, it is for both the library you're using, but even more importantly, the version you're on. Okay, so let's keep this going. We'll run and we'll wait and see if this shows up. Wait for element is not defined. Oh, right. I'm on the latest version though, because I installed this 3-4 days ago. So I'm going to use wait for, but in your version, it's still called wait for element. And this passes. Okay. So that means that after here, we must have the ability to start to add bugs. I want to fire event, click. I'm going to get by text console.log, or no, fix bugs, right? Fix. I think this one's actually called, oh no, fix bug is what we put there, right? So click the text and then expect get by text. And that's going to be, I think just, oh wait, that's going to be in the status, in the format function. So you have fixed one bug is what we would expect to see after clicking that button. And if I try and do that again, and I see, and I try to see 2 now, that should fail that last one. But I can just take this event here and make sure that works. Interesting. Okay. So, oh, that's why. I copied and pasted it. It has to be plural here. And it's telling me, I was able to tell from the output, you want to read this. I know it's a little bit, but you want to read it. Unable to find an element with the text, you have fixed one bug or two bug. Okay. No, we found the text, you have fixed two bugs. So that's actually what we wanted to put in there. So that helped me add the S. Okay. So now I would probably add, I gotta click it 10 times before I have enough money to buy an upgrade, let's say. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now I would expect there to be that I fixed 10 bugs. This is all a test I would do manually, right? Like if I'm actually testing my app, I'm going to go through and click the button and check the text, and then I'm going to click the button and check the text, and I'm going to click the button a bunch of times until I see 10 there. And then I'm going to go and I'm going to buy an upgrade, and then I'm going to check to see if the BPS has changed. All I'm doing is converting that into an automated test. Let's see if, yes, make sure this works. So do we have 10 bugs? Yes, I think so. Okay. Now, fire event click. We're going to find the thing that has the console.log with a 10 on it. And here, I think we want to see whether or not this value goes back to 0 first. Because we've just spent, you have no, I think it was you have no bugs fixed. I'll just double check. You have not fixed any bugs. So that's what we expect it to go back to when we spend all of our money on that one upgrade. I'll keep making sure this works. Good, that's passing. Now what I can do is I want to see whether or not, also I want to see what the bugs per second is now. So that's going to be fixing one bug per second is the text that I expect to see on my page right now. And if I'm unsure if that, I want to make sure that changes. I can also check to see whether or not it says the default value first, which was in format. So no auto fixing. So we start off, say you've not fixed any bugs and no auto fixing. We'll fix, and then we confirm that afterwards it changes to fixing 1 bugs per second. Or 1 bug per second. But now we want to confirm that the actual fix per second also increases the bug count. So we need to wait for that timer to fire before we do our next check. And we can do that by saying advance timers by time 1 second. Now I'm telling the actual, that auto fixer hasn't really run its timer yet, but now I want it to. And so I should see that it goes back to you have fixed 1 bug, because this is going to be the auto bug. Okay, here we go. An update to application inside a test was not wrapped in act. So it's that same issue again, that something here that I've just added recently causes a change to the state of the component that I'm testing. What is that? When my timer triggers, it increases my bug fix count by 1, which causes a re-render to occur. So I have to put this in an act call so that the test knows that I'm waiting for the re-render to, and React knows I'm waiting for the re-render to happen before I keep going. Cool? So when you see that, usually it's because some state is changing in your application, but the test is ending before that happens. And then that finishes it off. I feel pretty confident about that. I can go and run npm start. It's showing the loading indicator. Fix. And it's increasing every second as well. So I think that was pretty much everything I wanted to cover today. I'll have to figure out how to get it, maybe get that introduction a little shorter so we can spend more time on the live coding. I will just review my notes and make sure that there's nothing that I've completely missed. I think we talked about debugging quickly. There is another way to debug as well. You can use, I think, pretty DOM. So I've actually only linked the documentation to this. But this lets us take any element and console log its value, rather than with debug, it's taking the entire DOM tree that we have right now. So there's two ways to do it, either more generally everything or pretty DOM with it and pass it an element to render or to debug. We didn't talk about setup and teardown because we didn't have any need for it in this application. But setup and teardown is essentially this idea that we can commonize things that need to happen before every test into one function. So we'd create a function called before each. So if we wanted to have before each of these tests run, we needed to, I don't know, do something. We would create a before each method, and we would do common stuff goes here. Before each test is run, it'll run this function for us as well. Okay. Am I showing the right thing right now? No, I'm not. Here you go. Put a before each inside of the describe, and it will be before each of the tests inside here. Before all will only run once before all of these tests do. And guess what the fourth one is? Right. So we can also do after all. You will be doing some form of this because when we write integration tests, for example, before every test, you'll want to reset your database to a known state. You don't want your database to change after every test is run, because then every test needs to be run in a certain order, and it has this dependency and it expects something to be there. So what we do is we have a before each that will reseed the database to predictable results before every test is run, so that nothing changes it as tests are going through. So that's why we have that setup and teardown. And the last thing, I mentioned this a little bit today. I alluded to it with that act, for example. I think some of your apps will break today, and you might need to wait for an element. You might need to make the test asynchronous. Wait for an element to show up before the test finishes. That might solve some of your problems. So here, I have to fix that. Indicate, not indiate. Here's another thing. Code that mutates underlying state will change initial test values. So if you are doing tests for get interviewers by day, and you pass in a bunch of seed data, and you have 3 or 4 tests, and some test changes that seed data, then the next test will get that altered seed data and likely fail because of it. So that's another thing I've seen people run into before, is simply by writing code that mutates underlying state, the tests no longer work as they did before, even though the app seems to work just fine, right? That's the scary part about this, is the app seems to work just fine, but then when you write tests, it actually exposes that we may have been doing bad practices. I've also seen it where people have implemented updating spots by refetching from the API. If you think about that API, it has logic in there that when I book or cancel an interview, it changes the number of spots for me. So that's great. That makes sense. But if I mock those API calls, then that logic is completely gone. And the mocks will only return what I tell them to return, which are pretty much static objects. So it won't actually update spots in the tests. And we should be doing all of that on the client anyways. So I've seen people run into issues before where they took that shortcut, and then when the activity asked them to write tests that depended on mocking, they had to finally change the implementation for their application to do the best practice of update the local cache without having to make another API request. That's it. Thanks for the extra patience. Like I said, I didn't expect this to be as long as it was, but most of you are still here. I'm available until the last one leaves. If people have questions, so let me know what you need, and they don't have to be just about these topics today. Although, ideally, at first, I'd like to cover stuff about the testing, and then if people stick around long enough, we can talk about anything. What do you think?
Thank you.
You're welcome. Yeah. Bye. Also, if you happen to go through some of the code in the application we worked on and have questions about that tomorrow or the next day, that's okay too. So just send me a message on Slack. Thanks, Eric. Appreciate it. Yeah, thanks everyone.